Day 308 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem. And today we have question number 47, Permutations 2. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description and get you some. Now let's see what the question says. The question says, given a collection of numbers nums that might contain duplicates, return all possible unique permutations in any order. So now that we've read the question, let's go ahead and take a look at these examples to make sure that we're doing this question correctly. So in example 1, we have the input nums equals an array of integers 1, 1, and 2. The output is all different ways we can order these numbers from the input array, right? So these are all the different orders that we can arrange these elements from the input array, right? So we could do, it's a 2D array of integers. We could do 1, 1, 2. We could do 1, 2, 1, and we could do 2, we could do 2, 1, 1. These are all the different ways that we can order these numbers up here, right? That's what we're doing. So let's go ahead and look at example 3, where it might be a little bit more difficult, or there's a little bit more ways that we can order them because there's no duplicates in example 2. In example 1, there's duplicates. That's why there's only 3 different ways we can order those elements. But example 2, we have no duplicates, so there's a little bit more ways that we'll be able to order or structure these numbers. So in example 2, we have the input nums equals an array of integers 1, 2, 3. The output is a 2D array. First way we can order them 1, 2, 3. Then we can order them 1, 3, 2. Then we can order them 2, 1, 3. Then we can order them 2, 3, 1. Then we can order them 3, 1, 2. Then we can order them 3, 2, 1. So those are all the different ways that we can order these elements right here, right? And that's what we want to return, each different way that these numbers can be ordered. So now that we understand the question, let's get into the fun part, the actual solution, y'all. Solution is not that difficult, so let's get into it. So first thing we're going to do is we are going to create us a helper function that will help us to complete this solution. So the first thing we're going to do is we're going to say private func, we'll call it DFS, open up the parentheses, it'll be _r colon. So DFS for depth first search, we're going to do some backtracking here. So then we're going to say _r, we're going to say inout. That's going to be a 2D array of integers like this. So square bracket, and put the int inside. Then we're going to say comma, we'll say underscore, we're going to say p colon. Then we're going to say inout. That's going to be an array of integers as well. So square bracket int, or not as well. This is an array of integers. This will be a 2D array of integers. Then we're going to come right here. We're going to say comma. We're going to declare another variable by saying _v. Going to say colon. That's going to be inout, and that is going to be an array of bools. So square bracket and put boolean, or put bool inside the square brackets. Then we're going to say comma. Then we're going to say _n colon. That's going to be an array of integers like that. Now we could come outside of those parentheses, open up the bracket, and let's get started. First thing we need to do is we need to check if the current path has the same length as the original array, and then we can store the permutation. So in order to do that, we can say guard p.count exclamation point equals n.count. Else we could open up the brackets and we could just, we could say r dot append, open up the parentheses, p. Then we'll come underneath that and we could just say return. Boom. Now let's get started with our for loop. So we're going to say for I n 0 up to n.count. Open up the brackets. We're going to, so we need to skip the number if it's already been used to avoid duplicate sequences, right? Because we want unique permutations. So we are going to say, if v square bracket I, come outside of that, or, so vertical line, open up the parentheses, I is greater than 0, and two and signs, in square bracket I, come outside that square bracket and say equals in square bracket I minus 1. Then we'll come outside those square brackets, say and two and signs, v square bracket I minus 1. Just like that. Then we could just continue, and that's going to just skip the duplicates for us. So yeah, we just say continue. Boom. Then we need to add the current number to the path. So we could say come outside of this. To do that, we could just say p dot append, open up the parentheses, in square bracket I, just like that. And we need to mark this number as visited. So we could just say, hold on, come underneath this, and we could say v square bracket I equals true. Excuse me. Square bracket I equals true, just like that. Then we need to recursively generate our permutations. So for that, we could just say DFS, open up the parentheses. We're going to say and R, because when we're dealing with when we're dealing with in out, we have to use this and sign right here. So we're going to say and R, comma, and P, comma, and V, comma, and N is not in and out, so we could just say N, just regular like that. Now we're going to use the backtracking to remove the last added number. So we could just come right underneath this, and we can say P dot remove last. Boom, and put some parentheses at the end. Then we're going to say V square bracket I, and set that equal to false. And that's going to reset the visited flag for backtracking. So now that we've created our helper function, let's get into the main function. So in the main function, first thing we need to do, we're going to declare a variable. We can call that res, and we can set that equal to a 2D array of integers. And this is, and come outside of these square brackets and put a parentheses. This is where we are going to store our result, or our output, right? You see our output is a 2D array. So that's why we're making this a 2D array, because this is where we're going to store it. Then we need to declare another variable called path. So we're going to say declare variable. We're going to say var path equals, that's going to be an array of integers. So square bracket int, open up the parentheses. Notice that this has two square brackets. This only has one square bracket. And this is a temporary list to store the current permutation path. Then we need to declare another variable which is going to keep track of the visited elements. So in order to do that, we could just say var vis, set that equal to square bracket bool, so an array of booleans, open up the parentheses, and to just for a default value, we're going to say repeating, colon, it's going to be false, comma, count, colon, and it's going to be up to nums.count, whatever that may be. Now we need to sort the input to handle the duplicates easily. So that's where we call our helper function, and we're going to say DFS, open up the parentheses. Once again, these are in outs, so we have to use this and sign. We're going to say DFS and res, comma, and vis, comma, and, or excuse me, no more ands, just after that, comma, nums dot sorted, open up the parentheses, by, colon, and then put that less than sign. Then all we have to do is come right here, and we can say return res, just like that, y'all. So let's give this a run. Make sure it runs like it's supposed to before we submit it. Oh, we got an error. Was the error say? Let's see. Missing argument. So, oh, sorry. This should be, we didn't do the path. I had a feeling we was missing something. So it should be and res, comma, and path, comma, and vis. Now let's go ahead and run it again. See what happens this time. Let's see. And it's accepted, y'all. So let's go ahead and submit it now that we know it's accepted and it works. Hopefully it's still accepted after we submit it. And look at that, y'all. 2 milliseconds beats 60.83% of users with Swift, y'all. Not too bad. We'll get those numbers up as we continue down our LeetCode journey. Right now, we just want to be able to solve the problem that's presented to us. And I feel like this is a good solution for that because it's simple and easy to understand. So with that being said, y'all, make sure you get one more look at the code. This is the top half. This is the bottom half. Read it, learn it, love it. And with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.